For the younger generation, as they have the same rights to continue their education to a higher level, growing in knowledge, enhancing good character, and to have a brighter future. Universitas Terbuka is established to make the dreams of young men and women from all corners of the country come true through the distance higher education system to meet the ever-changing demands of industrial and technological development in the 21st century.
Dengan diresmikannya Universitas Terbuka.
Universitas Terbuka is a pioneer of world-quality distance higher education, which is supported by professional lecturers who are experienced in their own field of expertise. Universitas Terbuka has also made numerous innovations to solve current educational challenges by applying a digital learning ecosystem to build capable and quality future leaders.
Hampir 4 dasawarsa UT mengabdi untuk bangsa. Universitas Terbuka mewujudkan pendidikan tinggi untuk semua.
With the long experience of carrying out our mission of providing equal access to higher education for everyone in Indonesia, Universitas Terbuka has proven to be a trusted public higher education institution. Our graduates have successfully applied their knowledge into their chosen career fields as either professionals or entrepreneurs. As of 2022, UT has a student body of just over 350,000. As a cyber university who teaches and applies the latest technology, Universitas Terbuka has 4 faculties, including the Faculty of Economics, the Faculty of Law, Social and Political Sciences, the Faculty of Science and Technology, and the Faculty of Education and Teacher Training. As a successful distance higher education institution, UT has received various awards and achievements. For instance, the rector of Universitas Terbuka, Professor Ojat Darajat, was elected by acclamation as the president of Asian Association of Open Universities for the period of 2020 to 2022. Time and time again, UT continues to make important innovations by using the most advanced communication technology and information available in each of its programs. Through the implementation of lifelong learning, UT also provides certificate programs and tuition-free programs such as open educational resources, as well as free lectures to be accessed by everyone. Limitation is not a hindrance for people to continue their education to a higher level, because education is a fundamental human right for everyone that can be accessed easily. This is Universitas Terbuka, always thinking forward, always open to diversity.
Pendidikan tinggi bagi semua anak negeri.
Universitas Terbuka menjangkau yang tidak terjangkau.
Ladies and gentlemen, the visiting lecture session will commence shortly. So we would like to please kindly take an IC, turn the camera on, and also put your microphone in muted mode. All of the participants of today's event will get a certificate by filling the attendance form by clicking the link that will be shared at the end of today's event. Ladies and gentlemen, before we officially start the visiting lecture, please allow us to broadly go through the agenda as follows. We already watched the profile video of Universitas Terbuka. Next, we will sing the Indonesia's national anthem. And then we gotta have an opening prayer. Next, we will hear welcoming speech that will be spoken by Dean of Faculty of Science and Technology of Universitas Terbuka, which will be represented by the Vice Deans for Students, Learning Services, and Partnerships of Faculty of Science and Technology. And we will have a photo session, and Next, we will have the visiting lecture session and delivering certification of appreciation to our speaker, and we will have the closing ceremony. First of all, allow me to extend our warmest greetings to Honorable Speaker Professor Maria Mercedes Tan Rodrigo from Ateneo de Manila University from Philippines. And also we would like to welcome our honorable guest today, Dr. Subekti Nurmawati MSE as the Dean of Faculty of Science and Technology of Universitas Terbuka, Dr. Dewi Julia Ratnaningsih SSE MSE as the Vice Dean for Students, Learning Services and Partnerships of Faculty of Science and Technology of Universitas Terbuka, Head of Study Programs on Faculty of Science and Technology of Universitas Terbuka, especially Dr. Anda Dwi Astuti Aprijani MCOM as the Head of Information System Study Program, and also Dimas Agung Prasetyo Eskom MSc as our moderator, and all of the participants of today's event. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan. Welcome to the visiting lecture with the theme of eye tracking and the novice programmer today on Thursday, 26th of October 2023, live from Auditorium. Good afternoon and a very warm welcome to all participants who are joining us physically or virtually using Zoom and YouTube. This visiting lecture session is proudly presented by Faculty of Science and Technology of Universitas Terbuka, especially Information System Study Program. First, I would like to introduce my own self first. My name is Safira, and it's such an honor for me to be the host for today's event. Ladies and gentlemen, to begin our beautiful event today, let us listen and sing together the national anthem of Indonesia. Please stand up. Thank you. Please have a seat. Ladies and gentlemen, as we gather here today, let's pray together according to our respective gods, beliefs, and religions. Please start praying. Finish. Amin ya Rabbal Alamin. May God gives his blessings and grant our wishes. Ladies and gentlemen, let us hear a welcoming speech from Dean of Faculty of Science and Technology of Universitas Terbuka, which represented by Vice Dean for Students, Learning Services, and Partnerships for Faculty of Science and Technology of Universitas Terbuka. Please welcome Dr. Dewi Julia Ratnaningsi, SSI, MSI.
Hello. Thank you. Hello, hello. Thank you, Ms. Alfira. I'm sorry, my dean couldn't give a speech because her voice was lost. Maybe she's tired. Assalamualaikum warahmatullahi wabarakatuh. Good morning and best wishes to all of us. Alhamdulillahi Rabbil Alamin. In this very fine day and good health, we are able to gather in this forum. And this is our privilege that we can join in the hybrid meeting. Our Honorable Professor Maria Mercedes T. Rodrigo, PhD, from Ateneo de Manila University, our Honorable Vice Deans of the Faculty of Science and Technology, Universitas Terbuka, all head of study programs, especially Information Systems study programs, Faculty of Science and Technology, Universitas Terbuka, Dr. Randa Dwi Astuti Apriyani, MCom, all lecturer of FST Universitas Terbuka, Head of Technology, Information and Communication Unit UT, Pak Dimas Agung Prasetyo MCom as moderator today, and students of Information System Study Programs, Faculty of Science and Technology, UT, who attend virtually. Firstly, praise is to Allah subhanahu wa ta'ala because of his permission. Today, we are able to attend the visiting lecture from our extraordinary speaker, Professor Maria Mercedes T. Rodrigo, PhD, with the topic Eye Tracking and the Novice Programmer. Mr. Maria Mercedes will come to Universitas Terbuka. She was professionally a keynote speaker at Inodel in Yogyakarta. Today, she will share the topic with all of us. This event is organized by the Information System Study Program. Their visiting lecturer participants. In this visiting lecture, we will discuss many things about eye tracking, especially for beginner programmer, including introduction to eye tracking, structuring eye tracking studies, eye tracking data analysis methods, visualizing eye tracking, and finally, how do programming students read and analyze error messages? It is very related to our student who currently studying in information system study program. As a piece information, the number of information system students in the most in FST-UT with a total number of more than 15,000. So in visiting lecturer activity, it is hoped that it will broaden in insight not only for lecturer, but also our students. Ladies and gentlemen, hopefully after attending in this lecture, it can inspire us to continue working to develop research related to eye tracking in programs. We express our gratitude to Professor Maria Mercedes for her time and sharing. I would like to thank to the Information System Study Program for continuing in this good activity with Ateneo de Manila University. We hope there will be continued collaboration. Finally, we would like to thank all the parties, and we have not mentioned one by one who have helped organize to today's visiting lecture. That's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Devi, for giving a warm speech for today's event. And next, we would like to invite all the participants and guests who attend physically here to the front, and also the speakers and moderators, because we have a photo session together. And also for the participants that joining us virtually using Zoom, please open your camera once again, because we gotta have a photo session here. Okay. Sir Rodri, also Mr. Dimas, and also all the participants here to come to the stage at the front to have a photo session together. And also to all participants that joining us virtually using Zoom, please open your camera, because next we will have a photo session together. Okay, we're still waiting for the participants who attend physically here to get ready. Okay. Still waiting for the participants who attend physically to get ready. Okay, and also once again, I would like to inform to all participants that joining us using Zoom to open your camera. Okay, let's put this best smile of us. 1, 2, 3. And also the other one. 1, 2, 3. Cheese. Okay, thank you. You may have your seats again. Okay. Before we move to the next, our main agenda of today's event, the visiting lecture session, I would like to convey the vision missions of Information System Study Program. So the committee will share the vision and mission for participants that joining us virtually, and I would like to read the visions and missions in English. First, the vision of Information Study Program is becoming an excellent information system study program and having regional perspective through open and distance higher education system. And Information Study Program has 4 missions, which the first is providing access to open and distance with high quality in information system to every kinds of society. And second, developing learning system which based on analytical systematical thinking in information system field. And the third, reviewing, developing and utilizing the results of the reviews for information system field and its application in order to improving the quality of study program. And last, the fourth, disseminating the results of reviews for information system and its application in responding to needs of society. So next, distinguished guests and all participants, we will now continue to the main agenda of today's event, the visiting lecture with the theme of eye tracking and the novice programmer that will be delivered by our honorable speaker, Professor Maria Mercedes Tan Rodrigo. She is a professor from Department of Information System and Computer Science from Ateneo de Manila University from Philippines. And also for this section, I would like to give attention to all participants that joining us virtually to turn off your microphone during the presentations. And also if you have any question, you can write it down to the Q&A section or the chat box with format your name underscore your institution or UT daerah. And then you can write down your question, and also you can ask directly using the raise hand feature. And it is expected that all participants to fill the attendance form with the link that will be shared on the chat box at the end of the presentation. And Ladies and gentlemen, this session will be moderated by Dimas Agung Prasetyo, Eskom MSG. Mr. Dimas is one of the lecturers in Faculty of Science and Technology of Universitas Terbuka, especially Information Study Program, and also the Director of Information System Unit in Universitas Terbuka. Now, Mr. Dimas, time is yours now.
Thank you for the opportunity. Bismillah. Assalamualaikum warahmatullahi wabarakatuh. And hello, good morning, everyone. Dear Honorable Leader from the Faculty of Science and Technology, Universitas Terbuka. Dear Honorable Leaders from study programs at UT. Dear fellow university lecturers who were present directly and indirectly using Zoom. And the last to whom I'm very proud of, fellow students from all over Indonesia and or even the world on this beautiful meeting, in this beautiful session. I, Dimas Agung Prasetyo, fortunately being appointed as a moderator for this activity, and my personal hope is this activity can broad your insight and knowledge, and also give us some more understanding related to the topic we discussed today. And we currently have very extraordinary guest, and I'm sure that her experiences and her insight can provide new horizon for the topic that will be discussed today. And distinguished participant, please welcome our honorable guest, Professor Maria Mercedes dan Brodiku. And maybe and she will deliver a very interesting topic today, and related to the artificial intelligence and also machine learning, and especially in vision technology, and how this technology might help student or novice or beginner during their coding activity. And before Professor Maria speaks, I will read her CV in summary. So Ibu Maria Mercedes dan Rodrigo is an executive director of RIT and a professor at Department of Information System and Computer Science. She is also the head of the Ateneo Laboratory for the Learning Science, a member of the TPD at Scale Coalition. Her fields of specialization are technology in education and educational data mining. Most recently, she and her team have developed a mobile game for literacy and augmented reality application for museums. Okay, to Ibu Maria, the session is yours.
Hello, thank you. May I share my screen? Oops. Sorry. Okay. Hello, good morning to everyone. I can do it. Thank you. Good morning to the leadership of Universitas Terbuka. Good morning to the leadership of the Faculty of Science and Technology, to the faculty, and to my fellow teachers, to the students who are online. Thank you for this opportunity to share with you some of the work that is being done in my laboratory, the Ateneo Laboratory for the Learning Sciences. Thank you also, Dimas, for the very kind introduction. I just wanted to make one correction to my biography. I am the former executive director of Arete. My term as executive director actually ended already, and so there is a new executive director. Nonetheless, thank you for being so warm and so welcoming. I am very grateful to our Indonesian hosts for their kindness, their hospitality, and I'm truly delighted to be here. Okay. The research that I'm going to share with you today is on eye tracking and how we have used it to study novice programmer behaviors. Just as a show of hands, may I know if there's anybody in the room who has already worked with eye tracking before? Nobody yet. What about online? Have any of our participants online worked with eye tracking before? Nobody. Okay. Then online, did anybody raise their hands or no? Okay. Um, okay. So this will be, I hope, interesting and hopefully somewhat new. Um, this is the outline of my talk. I'll start with an introduction to what eye tracking is. I'll talk a little about how we structure eye tracking studies, and then how we go about analyzing the data and visualizing the data. And then finally, I'll talk about the research that we're doing in my lab. One of the things that I want to start with is to say that eye tracking is actually something that you can use for almost any discipline. It isn't you. It can be applied. We apply it to computer science, but you can apply it to marketing, to psychology, to um, even to reading and language. It's a technology and it's a method of research that actually lends itself quite easily to any discipline. And so hopefully, even if I realize that I'm talking to the Faculty of Science and Technology, but if you have colleagues who are not from this faculty but from other faculties, they may find this method actually useful for some of the research questions that they want to answer. So what is eye tracking? Eye tracking is a method of capturing or quantifying visual attention. Our eyes indicate where we are focusing, what we are paying attention to. And they're also an indication of what we find interesting. So if we as researchers and as faculty members want to know what our audience is focusing on, what our audience is finding interesting, then eye tracking is actually a good way to measure that. The visual attention refers to focalization. So focus. What are you thinking about? What are you how are you sort of excluding all the other uh, stimuli in your visual field and actually zeroing in on a particular area? One way to illustrate this is, well, this is a painting by Vincent van Gogh, and and one way to illustrate this is a method called tilt shift. And it's by an artist called Serena Malion, and you notice that she has blurred out the parts of the periphery, the peripheral parts, and she has focused instead on this central portion. So everything, and that's what happens when we concentrate on something. If I stare at, let's say, the coffee cup, everything else in the surroundings is actually blurred, but the coffee cup is very sharp. Another illustration, also by the same artist. So this is another painting by Van Gogh. She focused this time on the boats that were at the corner of the painting, and so the boats are very sharp, but the surroundings are quite blurred. Okay. We are interested when we study eye tracking. We're interested in where our eyes go. We are interested in which parts of the stimuli are what capture our attention, and also we're interested in things like the sequence in which we look at certain stimuli. Uh, we we can control where our eyes go. So even when you think that you're staring at one particular spot, your eyes are actually are never stable. They're always moving around. And so the question is, where exactly are they moving around? In eye tracking, we're also interested in identifying what the focus of the attention means. So if we are if we stare, for example, at the coffee cup, maybe it's because I am thirsty, and so I'd like a cup of coffee. Versus, so anything we look at has some kind of meaning to it. So if my eyes go from, let's say, the coffee cup to the clock, why am I looking at the clock? Maybe I'm checking if I still have time in my talk or how much time I have left. So, whenever we look at something, it's because there is a particular meaning that we attach to it. And so we're interested. What is the meaning of that thing that we are looking at? Okay, how do we structure eye tracking studies? First, you have to start with a question. What is it that you want to find out? And normally, we are interested in things like what is it that people are looking at? What is it that they notice first? How long do they look, or how long before they notice? So think of it. Let's not talk about novice programmers. Let's talk about, let's say, a marketing study. Let's say you are showing two different packages, two different designs for soap. You have package A, which has, let's say, a small leaf, and package B with a big leaf. Which one do people notice first? Do they notice the package with the big leaf, or did they notice the package with the small leaf? And this might have an implication on which packaging you will actually use for that bar of soap. If people like the small leaf more, they will look at it more. They will notice it first. They will look at it longer. Um, and and maybe that's something that you can use to actually package your soap. Or for example, if you are shopping uh, for, let's say, different for a snack, you want some chips or some kropik or something like that. Which is the package that is most attractive to the eye? Is it the package that's in orange, or the package in green, or the package in red? Which one do the consumers look at? And so when you go to the supermarket and there are all these different packages of snacks, and the consumer walks in, how do they scan the shelves, and which one sort of grabs their attention? And does that translate to an actual sale? Will they actually pick up the bag of snacks and buy it? So these are the things that we are interested. So we have to ask, what kind of question? What question do we want to answer? Some of the past studies on eye tracking have looked at, for example, fashion design. So if you are selling handbags, um, they took a so there's a scientist from Taiwan, Dr. Hong Fa Ho, who studied what women look at while they look for bags in an online shopping application. So they photographed different types of handbags, but same white background, same size, more or less. And they tried to see, does the lady look at the handle? Do they look at the branding? Do they look at the pockets? What do they look at? And apparently, I believe, if I remember correctly, it's the handle that they look at. So again, this might be informative if you're a handbag designer, that maybe this is something that you have to consider the next time you design a handbag. So things like that. Okay. So you start with a question. You start with a question. What is it that you want to answer? If you are a reading teacher and you want to find out how difficult the particular paragraph is, you can actually use eye tracking to answer that question. If the paragraph is too difficult, then the students will either spend a lot of time reading it, or they'll spend very short time reading it. Um, a very long time reading it because they're trying to understand what these different words are and what the meaning of the sentences is, or very short time reading it because they've given up. I don't understand this. I'm not going to read it. Or I'll stare at it for 1.2 seconds and then I'll just not deal with it anymore. So there's a sweet spot. There is an optimal amount of time you can spend on a paragraph to tell that students are engaged with it um, properly. And so you can see from eye tracking whether they're actually reading or whether they're skipping or whether they're not looking at it even. Because eye tracking can tell you those things. Um, Now, why is it that we ask these questions? We ask these questions to find out what people are thinking, and it also informs us about what to do about pricing, about placement, about design, and so on. Okay. Second thing is you select your stimulus. So, I mean, perhaps you have played games like this when you were children. I used to play these games all the time. You have to spot the difference between what is the difference between the left and the right. There are supposed to be 10 differences. I didn't actually try to find them all. Um, so but this can be any stimulus. Okay, I just chose this one. This is just an example. So usually if you think about what your eyes are doing, you're looking maybe at this section first, then you compare it to this section, and then maybe you look at this section and then compare it to this section. Oh, I'm sorry. So you keep going sort of back and forth, right? Um, and so the first thing as a scientist, what you would do is you would choose the stimulus. So again, this can be any stimulus, but this is just an example. The next thing you would do is you would divide your stimulus into what are called areas of interest. Sometimes they're called regions of interest. So you put um, squares or rectangles around the parts that you think are interesting. In this case, I marked some of the things that were supposed to be different. So the rainbow, and maybe some of you have already seen this. The rainbow is slightly different. The the flowers here are different. There are 3 over there and 4 over here, and there are so you mark them. And the reason why we call them areas of interest or regions of interest is because you are hoping that this is what people will notice. You're saying that these are the important parts of the stimulus, and if people focus their attention on these areas, then maybe they are engaging with the stimulus. On the other hand, if they are not noticing these areas, then maybe they're not really paying attention or they're looking at the wrong things. So these areas of interest, they are defined by your research questions. What is it that you want to find out? And how does what you want to find out map to the stimulus? So one of the examples that I used in another lecture is, are you a dog person or a cat person? Do you prefer to have a cat as a pet or a dog as a pet? So I put the cat on this side and I put the dog on this side. And you can actually tell the dog people will have more um they will focus more on the dog, and the cat people will focus more on the cat. And you can just tell that by the number of times they look. They'll look far more on the pet that they like. Um, so that's your research question will determine what your stimulus is, and your research question will determine what where these squares are positioned. Okay. In the case of the study that we did, we gave we were interested in how novices read programming code. So we provided a description of the problem. So um, what the program was supposed to do. So there was a description, an input, an output, and then a sample. And you can tell from here, this is where the eyes of the student were reading. They didn't read the description so much. They read this part more because they could sort of infer from the sample input and sample output what the program was supposed to do. Now this circle, this oval over here, this was supposed to represent where the cursor was, and they are able to. Sorry, I'll go to the next page. When so this is the code that corresponded or corresponds to the description, and the instruction to the students was to mark where the bugs were. They used the oval to kind of encircle where the bugs were. So we knew we could. They have to mentally trace. So this is not a running. Sorry, how should I say? This is a screenshot of the program. So they don't have to compile the program. They don't have to run the program. They have to read it. And based on their reading of the program, they have to tell where the errors are. We tell them how many errors there are. So we told them in this case there are 3 errors. So can you find the errors in the program? And if you find the errors, encircle them by clicking on where you think the errors are. And then again, you can see this is where the eye gaze of the students, the participants went. Okay, then you collect your data. In order to collect your data, you can use an eye tracker. There's more and more. It is more and more possible to use a webcam for this. The problem really is accuracy. If you have a big area of interest, then if you have a big area of interest, your eye tracker does not have to be very accurate. However, if you have a very small area of interest, then accuracy is important. And you might want to use a specialized eye tracker. So in our case, we purchased this eye tracking device. It's called a Gaze Point GP3. And there are also what are called head-mounted eye trackers. So they're like eyeglasses that you can wear. This one, obviously, you cannot wear, so it has to be on a table. And we set up the tables to look like this. So the participant was seated here. They have the eye tracker under the screen. They have a keyboard and a mouse, and all of this is connected to the computer at the back. So the computer at the back is used by the experimenter, by the researcher. You run the program and the eye tracking software and the stimulus, etc., from this computer here at the back, and it's all projected on the screen here. So the user sits here, sees this, but does not see whatever is being shown on the screen of the experimenter. What the experimenter does at the start is they calibrate first to make sure that the eye tracker is accurately detecting the eyes of the participant. And then once that has been established, then they run the experiment already, the data collection. So they show the description of the program and then the code, and then they allow the participant to mark what they think the errors are. There are some limitations to the eye trackers because some of the eye trackers, I say that some of the eye trackers are racist. If your eyes are too small, it doesn't pick up the focus. Also, if you're wearing very shiny earrings, sometimes the eye tracker will pick up the earring and not your eye. If you're wearing glasses that are quite thick, sometimes the eye tracker will not pick up your eye. And if you're wearing contact lenses, sometimes sometimes you're not picked up. So there are some limitations. And that's why you need to go through that sort of calibration process. Okay. Now, what data will you collect? There are different types of data. They're what are called saccades. Saccades are when your eye travels from one point to another, that traveling is called a saccade. Fixations are stable gazes. So when you stare at a particular area or a small region for a certain amount of time, that's called a fixation. Sometimes pupil dilation is also counted, and scan path, so a series of fixations. I mentioned this already, that there are some limitations to eye tracking. There's accuracy. There's a difference between the true and measured eye gaze data. Sometimes, I was saying that some of the eye trackers have, all eye trackers have an accuracy. They have an error. They're not. There's always going to be plus minus a certain degree, and this this is this can be important if your area of interest is very small. Less important if your area of interest is very big. And then there's what's called drift. With time, the accuracy can diminish, and then of course you cannot capture peripheral vision. You can only capture the focal point. Okay. There are different ways to analyze the data. Once you have your data, what is it that you do? There are different metrics for analyzing fixations and saccades. You can do things like you can count number of fixations. So if you remember my example of, are you a dog person or are you a cat person? The more fixations there are on one animal, the more likely it is that you favor that animal over the other animal. It's not 100%, of course, but it's likely. You can look at fixation duration. How long do you stare at something? So if you're looking at handbags, for example, there's a collection of handbags. The longer you stare at one particular handbag, chances are that's the handbag that you want. You can look at the percentage of the ratio of number of fixations over on one AOI. You can look also at time to first fixation. So time to first fixation means that if you have, let's say you have a website and you have some news on your website, how long before your audience sees the news? How long before they notice that there is news on the website? And so on. There are other types of measures. There's also things like you can do saccade counts. How many times do you travel from one area to another? How long does it take for you to sorry. You can also look at things like regression rate. So what's the percentage of backwards? So if you have to go back and forth, like when you're doing the spot the difference game, how many times do you go back and forth from one stimuli to the other? So these are all things that you can measure. And again, what measures you use depend again on your research questions. You don't have to do all of these measures. It really just depends. You choose the measures that will answer your research question. Okay, so this is an example. So for example, this is the Crate and Barrel website, an old one. You can, when you define your AOIs, it's up to you how small or how big you want the AOIs to be. You can divide it into 3 AOIs, the top bar, the sort of the middle bar, and the bottom bar, or you can cut it up into more AOIs. So this one is 1 AOI per type of product. it really depends what you're after. Then how do you now interpret the data once you have performed this kind of analysis? There is some things that you might be able to conclude, or there are some implications. They're not reasonable implications. Now they are reasonable implications. The thing that your audience stares at the longest are the ones that gain the most attention. Um, the but this can be good or bad, because a long fixation might imply highly interested, or it might imply very confused. Okay. And the interpretation will need to be substantiated by maybe an interview or some kind of follow-up question. So, or you can be staring at a handbag because it is very beautiful. You can be staring at it because it's so ugly, right? I mean, it's like, oh my God, I'm never going to use that. I'll never buy that. Um, so you need to kind of do a follow-up. You cannot rely on this 100%. You need to maybe talk to your participants and ask them, oh, you stared at this handbag for very long time. This was the one you stared at the longest. This is because you liked it, or is it because you hated it, right? And so you can ask that question to substantiate your conclusion. In the case of reading, I already mentioned that if you keep if you keep staring at if it takes you a very long time to read something, or a very short time to read something, it could be because it's simply too difficult. Okay. You can represent the eye tracking data as something like this. You can put like how many seconds the person stared at particular AOIs. You can also, so the S here would be seconds, so the amount of time. You can also represent it as percentages. They stared at this part of the screen the longest relative to all the other parts. Which representation do you want? It again depends on your research question, and it depends on what is the most informative for you. You can, if seconds makes the most sense, then that's fine. Go with seconds. But if percentages make the most sense, then that's okay too. If you're interested in finding out, do people notice the change in your website, or which change do people prefer? You can represent it this way. So there's this AOI. This is an advertisement. This advertisement is in grayscale, and this advertisement here is in green. And you'll notice that when it's in green, the participants spent much more time, 17 seconds, staring at this versus, oh sorry, time to first fixation. Oh wait, sorry. I'm showing time in seconds. It took participants to notice. Oh, okay. So they actually notice this faster. They notice the white one faster than the green one, which surprises me. Now I'm not sure. Okay. All right. That's what it says, I guess. Okay, so it was fast. They noticed it took longer to notice the one in green, which is a surprise, than to notice the one in grayscale. All right. Sorry, I'm just checking the time. There. Okay. Thank you. Those are so what I showed you was the analysis of fixations and saccades. The more complicated type of analysis is the analysis of scan paths. And this is where those of you who teach computer science, and those of you particularly who are interested in graph algorithms, this is where a lot of your graph algorithms can come in. And so if you're doing like comparison of graphs, because essentially you can represent fixations and saccades as a graph, and you can use graph algorithms to compare one graph against another. You can also use algorithms like the Levenstein distance to check how similar or how different two scan paths are. You can use something called Matho's distance algorithm to compare, same thing, how similar or how different are two people's scan paths. And you can use longest common subsequence and many more. Okay. There are ways of visualizing eye tracking data. You can use something like this. So assuming that, actually, I have a better visualization for this. Okay. So let's say that you're trying to show how people look at the mobile phone. You can divide your mobile phone into three AOIs. AOI 3 is the bottom, the keypad, and then AOI 2 would be the where the buttons are, and then AOI 1 is the screen. And you would show sort of, okay, they stare at the screen, then they look at the buttons, then they look at the keypad, then they go back up and look at the buttons, and they go back to the screen, and so on. So it's a scan path, but it's laid out over time. Okay, and so you have you have, it looks like a signal, and it actually is represented as a signal. You can also represent it as AOI rivers, something like this. So the let's say the majority of your users start out somewhere here, and then they branch off to different AOIs. Sorry, I keep touching the screen. I shouldn't do that. Um, and it's interesting. It's a very attractive representation, and it also gives you a sense of where people go. So when they start off in the red, for they you can see they branch off to the blue. Some people branch off to the green, and it but the majority kind of stay here. And so again, it's a way of representing what people look at over time. This is another way, but anyway, let's, in the interest of time, let's move on. Okay, I'm moving now to the research that we've actually done. And the research question that we're trying to answer is, how do programming students read and analyze their error messages? This was a continuation of some previous studies that I did together with Dr. Christine Tablatin and a couple of other doctoral students. But I'll focus on what she did first. So she analyzed individual programmers and tried to differentiate how high and low performing students looked at code or read their code. And what she found was, and this is just a few examples, there's she looked at they have similarities and differences. So high performing students and low performing students will do this, something that she calls a scan pattern, which is more or less, they'll look at one part of the code, and they'll just kind of try to get a broad sort of overview of how the code is structured. So they go up here, they see the class definition, they go down, okay, it's a bunch of print line statements, and they go back up and they try to, so it's like they do a quick scan of the code. So that's one pattern that emerged. High performers do something like something that she calls jump control, which is that they try to follow the logic of the code. So you'll see that they start somewhere here in the middle of the loop, and then they go up here to the outer loop. They try to they jump to the main, then they go back down, and so, but it's this traversal that you're interested in, from 1 to 2, then they go outer loop, they go inner loop, they go outer loop again. So they try, you can kind of suspect that maybe they're following the logic of the code. High performers also do something like what we call a word or pattern matching. They see, in this case, they're looking at the counter variables. K is a counter variable, I is a counter variable, J is a counter variable. So they're looking at all the counter variables and they're thinking, okay, these are all the counters. So they're looking at the pattern um, of the different counter variables and where they're placed. So this is again a characteristic of the high performers. Now, what do the low performers do? The low performers do something called flicking. You can see that they're the this the student here looks at the input statements, stares here for a little bit. Maybe this is an artifact of the error rate that I was talking about. Maybe they were really staring here. We're not really sure. They go down. They don't quite get to the loop. Then they go back up and they look over here. So it's almost like they're avoiding this part, which is the hard part of the code, right? This part, these are all the declarations. So these aren't, I mean, there's only so much processing you can do with declarations, but they really should be engaging with this part, which is the harder part of the program to understand. So it's like they go here, that's scary, let's go back. So that's um, the other thing that low performing students do is something called thrashing. Um, they go all over the code with no real direction. So they go to the declaration, go back to static void main, they go down here, they look at the output statement, they go up um to the outer loop. But again, it's like they're not really following the logic. Neither are they touching the common variables or the patterns. They're not quite sure what they're looking for in the code. So it's a little this kind of analysis requires you to of course uh it's a little like reading tea leaves because you're trying to figure out what is the student thinking and um what might be going on in their heads, right? They're going to all these different places. What are they what is the commonality? What is the essence that they're looking for? So but we classified this as thrashing because there doesn't seem to be much commonality and much sense. Okay. Um, so the current study is a continuation. We were interested in whether students actually read error messages. And because error messages are actually sometimes quite arcane, they're quite difficult to understand. So how do novices actually make use of them? um, some of the ways that computer scientists have addressed this is to try to create students systems that enhance error messages. So they've provided more subheadings, um, color coding, progressive messaging, um, and some findings inform us that, um, however, I should say, some findings from these studies inform us that providing this extra information does not necessarily help students debug their programs more. So, is it worth it? Is it worth it to invest this much effort and this much research and this much grant funding um, to on better and better error messages? So we ask, do students even read error messages, and how do they act upon the error messages if they do read them? There is some related literature on programming comprehension, which I will not get into because of time constraints. We also discussed the research that we've done. There are methodological considerations that we put together, and we looked at we're looking at things like we pretest the programmer the actually, okay, let me make a correction here. In our initial proposal, we wanted to determine initial level of competence in programming. However, we scrapped that portion and we just went instead with the self-efficacy measure. How good do they think they are with programming? We also looked at personality factors. Okay. And then for the analysis methods, we look, of course, at fixation counts for fixation duration, and then we will eventually go to a scan path analysis. Okay. So our hypothesis here was that the more efficient and more self-efficacious students read the error messages, but limit the reading to the line number and not to the actual error message. So in other words, they don't really care what the message is. They just want to know where the error is. That was the hypothesis. And we suspected that the less proficient or less self-efficacious students may actually read the entire error message. Now, this is work that I'm doing with Karen Pacol, Dr. Karen Pacol, who is my postdoctoral researcher at the moment. So she should have a PhD. I'm sorry, I should have added that. And I have to leave you kind of hanging at the moment because we're not actually done with the analysis yet. So far, what I can tell you is that the more proficient students tend to actually spend less time with the error message. They spend statistically significantly less time with the error messages than the low performing students. So the low performing students really spend more time with the error message than the high performing students, which kind of confirms what we probably already suspect, that the high performing students are the ones who are very efficient. So they don't really need to dwell on the error message that much. They can just move on to the code to try to figure out what exactly is wrong. That's the finding so far, and I think this is kind of where my talk ends. So thank you all so much for your attention, and I'm happy to answer any question.
Okay, give applause to Prof. Maria. Okay, yeah, we just listen what Prof. Maria shared. And I think in summary, I can give a brief summary. So the speech discuss about to answer question what people looking and interested at, and how the technology, especially vision tech, to help us understand how human using their vision, looking, skimming, searching, and pointing the object they interested. And I believe this research will be very useful in any area that requires object searching and in identification. And as far as I know, some international school in Singapore already use this technology to detect whether the student focus on the content during their Zoom by analyzing whether they are by analyzing their face, their eye movement, whether they are open any application and scrolling up and down during the Zoom session. And also in UT, we already have some research that use the same technology, vision tech. We develop online proctoring, Prof, that use the vision tech to detect face movement and also student gesture to detect whether they are nervous during the exam, and also whether they have tendency to do something that might be break the academic integrity. And I think some of you will have any question regarding this topic. So maybe we will have question session from you that present in this meeting or in the Zoom, maybe in the Zoom. If anyone want to ask a question, you can just raise your hand in the Zoom. Any question? Anybody? Okay. Miss Amas. Thank you.
Thank you. Thank you for thank you, Mr. Dimas. So I want to ask to Professor Maria. I really interesting in this topic because maybe this technology eye tracking we could find like people who have a low performer like they don't have don't have a focus and or attention in some object. Maybe we could find that maybe the student may have a impairing functionality like HD cognitive. So I would believe it would be some interesting to know about the person who have disabilities, something like that. But maybe is it only for for the finding of this research? Is it only maybe because this is correlate with the neuron or something like brain function cognitive? So maybe could we do some other assessment without using, for example, like to get the signal of the brain or something like it? Do you have an idea of this other assessment using other than eye tracking so that our evaluation which more reach to the founding? Thank you, Miss.
Okay, thank you for the question. I don't have any experience with these types of research questions. I would imagine that you could use it for uh, studying these phenomena. I would suggest that um, that this kind of work be done with, let's say, the Faculty of Psychology or medicine, even because they would have the correct sort of theoretical background for it. The reason why I'm doing studies on novice programmers is because I am part of the computer science department, and so I'm more familiar with this particular group of students and these types of research problems. But I do have a friend at the Faculty of Psychology in my university who is saying that you could use it even to study babies, because of course babies cannot tell you what they're looking at, but you can use it to try to see what they're attracted to. So I would imagine somebody like her would be able to, like a developmental psychologist, would be able to give the correct foundation for such a study.
Anyone? Okay, maybe I have one question.
Sure.
Maybe one simple question. Uh, f- uh, from a novice user who are interested in this topic of area, what they need to learn first in order to to jump to this vision tech, and what tools they need to have in order to try the technology.
Okay. Um, it's actually relatively easy to learn the first the basics, because if you buy the eye tracker, it and the software, it's quite fast to learn how to set it up and how to set up a simple experiment. Before the pandemic, I used to teach a class on eye tracking, and it was an undergraduate class. And my undergraduate students were able to set up experiments. I mean, little experiments in class. So, um, like one of them was interested in how to because there are these very popular. I don't know if you have them in Indonesia as well, but there are study centers where students can go to. If they have a hard time studying at home, they can go to a study center where that have tables and internet and juice and coffee and some cookies So it's kind of like an internet cafe, but it's specifically for students who want to study. So they wanted to find out which design of study center um, is most attractive or most comfortable for students. So they took pictures and they just it was that kind of a simple experiment. What is it that students look for? Um, and uh, so setting up those types of experiments quite fast. And then the metrics that you count, because the software generates those numbers for you. So the fixation count, the time to first fixation, etc. That the software will generate those statistics. So it's quite fast to run an analysis and to come to conclusions. The advantage of researchers such as yourselves is that you can make sure that the methodology is correct and rigorous. Of course, our young students, the undergraduates, they don't have as much experience. So maybe the methodology is not so good, and of course they don't have big numbers. They have maybe 5 participants, but you people in your level of experience will be able to get a good number of participants, etc. So um, you can design the experiment as long as you design the experiment well and get a good number of participants. Then generating the data is not actually difficult. When you come to the more sophisticated type of analysis, when you're actually, let's say, comparing scan paths, that's more difficult, and that takes more perhaps training and that's where the fancier programming comes in, and you really have to do some additional reading, additional searching for the right algorithms. But if the research question is quite straightforward and can be answered by number of fixations, um, or fixation time or something like that, that's quite fast and that can be easy to do. So the challenge is to come up with a really good research question and design the experiment so that the data that you gather is reliable and is representative.
Okay, very interesting. So, fellow students, you need to catch this opportunity, yeah, because as we know that today the AI or machine learning is a new trend right now, and the demand for AI expert or data analysis expert is high. So, I believe you should catch to the opportunity. And maybe any question? Okay. Okay, from Melissa. Hello, Prof. Maria. I will ask about what kind of artificial intelligence algorithm can use for the best eye tracking. Thank you.
What kind of
Technology
what kind
that
of artificial intelligence?
that can be used, the best technology that can be used for the eye tracking. Yeah.
The kinds of algorithms we use are more the data mining type of or learning analytics type of algorithms. For eye tracking specifically, the one that I showed my student Christine Tablatin, Dr. Christine Tablatin, she used something called scan path. Sorry, scan path. Let me. I will just go back to my slide because I want to be able to say this correctly. Here. Okay. Scan path trend analysis with a tolerance. That's what she used, and that's more, I would say, in the learning analytics area. I had another doctoral student who also finished already. So from Mindanao, who used something called cross recurrence quantification analysis. So, these are very sort of specific algorithms. They won't answer every research question. They answered very specific research questions. That's why they were used. So again, I would say start with your research question. What is it that you want to find out? And then there's an algorithm out there that will probably help you. But it's not one size fits all. There's no one best algorithm for it, because it really depends on your research question.
Okay, so Melissa, maybe I can add more some information. So maybe if you want a fast or ready to use service, maybe you can use cognitive service that provided by the cloud provider like Microsoft or AWS or Google. But if you want to learn more in depth about the technology, yeah, you should learn about the algorithm and also some theory that related to how the vision work, right? Okay. And maybe any question again from the Zoom participant and also from the direct participant? While waiting, I just realized that we have the same color of the cloth, black. Yeah, I'm assure you that this not on purpose.
Yes, not on purpose. We did that.
Okay.
Thank you, Sir Dimas. My name is Raji from the Food Technology Program. My question is only sort of related to what you've been explaining. So apologies if it's confusing. You mentioned before that eye tracking is being used in supermarkets as a way to gauge the attentions of the consumers itself. And it can be very positive for the producers because they can optimize the attention of the people. But it can be also be bad for the consumers because in a way it can promote bad behaviors and also obesity. So I think my question is, what do you think as someone who is involved in technology, think about the use of eye tracking in that manner? Thank you.
Yeah, that's a really good question because you're completely right. You're completely right because the research, this kind of research, especially when there's money involved, it's really the agenda is controlled by the interest behind it, right? For those of us in academia, we're not supposed to have those kinds of interests. We are just interested in the in how people behave, but we don't necessarily want to control their behavior, use that to manipulate their behavior. Maybe in the learning sense that if you find that, okay, this is the best way to read something, or this is how you should parse a diagram, we can use that to the benefit of our students. We can say, okay, if you have a diagram like this is how you read it, this is the correct way. So that is a benefit to our students. But you're right that if there is an agenda, a commercial agenda, the question can be, how can we manipulate our consumers so that they buy our product more, right? This is true also if I can just take a jump to computer games. The computer game companies try to find ways to make their games addictive, right? So that the replay value is greater, and so that people come back and play more and more. It's kind of the same thing now. So the question is, what your question is, what do I think, or what do I? Well, I think I would hope that when we at least use these technologies, that we can do so for the benefit of our students. I cannot really control how other people might use it, but maybe we can as academics and as researchers can well, okay, here's one thought. If we are aware that people are using this technology to sort of manipulate consumers, we can also make make our students aware that these these methods are being used on them. So maybe by promoting that kind of awareness, they can think more critically about their choices. That maybe the one with the shiny packaging is not necessarily the best product. Maybe they should be more sort of open-minded. Maybe they should scan more. Maybe they should read labels more. There's also the argument that many of our products come with nutrition information, and nobody ever reads nutrition information. Some people do. Maybe we should. This is a. If we find that indeed very few people read nutrition information, maybe this is a way for us to lobby for more visible nutrition information, or more sort of make nutrition information more easily noticeable, something like that. So, in other words, it ties into things like consumer rights and consumer education. Maybe that's one way to go about it.
Thank you. And the last question from Zoom participant. Good afternoon, Prof. I want to ask, how does an eye tracker work to recognize a pattern?
How does an eye tracker work to recognize
A pattern.
eye patterns?
Yeah.
Oh, it uses infrared. So the eye tracker sends an infrared signal, and it checks the infrared. I think I'm sorry. You have to please fact check me on this. I think the infrared bounces off your pupil, and that's what the eye tracker is able to detect. That's why if you're wearing very thick glasses or contact lenses, the infrared signal isn't able to sort of reflect off your pupil as much. I think I have to double check that. I don't know. Did that answer the question?
Okay. I believe we are reaching at the end of the session. And to Prof. Maria, thanks again.
Thank you.
From
Thank you.
the insightful and great speech
Terima
today.
kasih.
And thank you for the participant by direct and on the Zoom who attend this session. And I hope we all getting very good knowledge and new knowledge about this. And maybe, we can start to jump and to explore this technology. And thank you again. And the MC, I deliver the session to you. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning and thank you.
Waalaikumsalam warahmatullahi wabarakatuh. So please once more round of applause to Mr. Dimas and also our honorable speaker, Professor Rodrigo. And what an enlightening information that we have here by gathering and joining the visiting lecture session with the theme of eye tracking and the novice programmer. Once again, I would like to thank Mr. Dimas for guiding us through the visiting lecture session, and also we would like to thank our wonderful speaker, Professor Rodrigo. Once again, I would like to inform and also reminding to all participants to fill the attendance form with the QR code that committee had shared using Zoom and also YouTube. So once again, to all participants will get a certificate by joining today's visiting lecture with the theme of eye tracking and a novice programmer. So to all participants, can scan the QR code that we had shared and also can write or type down the link to the browser and fill the attendance form to get a certificate. Okay, next, as a token of appreciation to our honorable speaker, Professor Maria Mercedes Tan Rodrigo, for taking her time here and share a precious knowledge about eye tracking and the novice programmer. So we would like to give a certificate and also souvenir, which will be delivered by Dr. Randa Dwi Astuti Apriyani MCOM. So it is an honor for us to invite Miss Yang and also Professor Rodrigo to come on to the stage. Okay. So if you may, you can stay in here. Okay. And for the first thing that will be delivered is the certificate as the speaker of today's visiting with the theme of eye tracking and the novice programmer. And the certificate is delivered by the head of information system study programs. And so we will give a placard as a souvenir to Professor Maria Mercedes Tanroth as the speaker of today's visiting lecture with the theme of eye tracking and the novice programmer. Okay, the last one. Souvenir from Universitas Terbuka. Once again, give round of applause to our speakers and Mrs. Yani as the head of Information System Study Programs. Ladies and gentlemen, we have reached at the end of today's event. On behalf of the committee and the whole faculty, we would like to extend our gratitude for the speaker and all participants for your contribution for this event. And also, once again, I would like to remind you to fill the attendance form by scanning the QR code that already shared by the committee, or you can type down or write down the link on your browser and also fill the attendance form, and all participants that already filled the attendance form will get a certificate. And we hope today's event become a great experience for you to share knowledges, experiences, and inspirations. Hope to see you again on the next visiting lecture of Information System Study Program. My name is Fira. Thank you and have a good day. Say bye.